Here we are, unit 9.3. Let's get ready to solve some exponential word problems. Okay, so we're going to have two different kinds of equations here. We have non-rate exponentials and we have rate. Okay, each one of them has their own formula. Okay, you will be provided a formula sheet for your quiz and test here. Okay, but you have to know what each of the variables in the formula represents. Okay, so this is our first formula. This is non-rate. Okay, y equals a times b to the x. So this looks very, very similar to the form of when we were graphing. The a is your initial or your starting value, remember, at time t. At time 0, time is t, okay. B is the base, and that's going to determine if it's growth or decay, and then x is going to be your exponent. Okay, so we want to write an exponential equation that passes through these two ordered pairs. Okay, so you want to note there is something special about our first ordered pair here, because this is paired with 0. Okay, and t equals 0 is an important factor in exponentials. This is your initial value. It's your a value. So that means in this situation that a equals 6.4. Okay, so remember, we're using this formula, a times b to the x. We've already found one of the two values that we need in order to solve the equation. We found a. Now we have to figure out how are we going to find b. Okay, and we're going to solve for b using the ordered pair. So really similar to when we wrote equations of lines using y equals mx plus b. You always had to solve for b, and you used that other ordered pair as your x and your y. So we're going to plug all of this in. So 100 equals 6.4 times b, okay, and maybe we'll even put that in parentheses, to the third power. Okay, so using order of operations to isolate here, we're trying to get b by itself. First step is going to be to divide out that a initial value. And we get 15.625. This equals b cubed. Okay, so we're going to do something here called a cube root. So it's very similar to doing like a square root, which we've seen before. Okay, so there's a button on your calculator. If you hit 3 and then second, and you see the, I think it's on the square root button, you see right above the square root button, it has an X in front of it. Okay, that'll do the cube root for you. Okay, and when we're together in class the next time, we can talk about how to do this on the calculator, what buttons to use for which calculator. Okay, but for right now, just follow along with me. I'm taking something called the cube root, okay, and the calculator is going to do that for me. And we're going to get b equals 2.5. Okay, so I solved for b, but just like with y equals mx plus b, we have to write our equation. So we're going to plug back in just our a and b value, and I like to put everything in parentheses here. Okay, and then we leave x and y as exponents. Okay, so that is our final answer equation. 6.4 times 2.4 to the x. Okay, so still non-rate. Okay, Kristen starts an experiment with 7,500 bacteria. After 4 hours, there are 23 cells. So we now have to write these ordered pairs for ourselves. Okay, so I see it says that keyword starts. Starts an experiment with 75,000. Well, that's got to be my initial value times 0. And then at hour 4, there's 23,000. So those are my 2 ordered pairs, and I'm going to plug them in just like the last example. So this ordered pair is going to be x and y, but the ordered pair with 0, that gives me my a value. Oh, I'm sorry, not b, or not 4, rather. There we go. 4 is my exponent. Okay, so we're going to have to bear with the numbers that we get here. Okay, when I divide out that initial value to get b by itself, right, I get b to the 4th. Well, this number on the left does not divide evenly. So I can cancel out some zeros, but I still get 230 over 75. So we want to just simplify that fraction down. Okay, but we're not going to turn it into a decimal because it's not going to come out nice that way. It's not going to come out nice as a decimal, and we need it to be exact, okay, because we want to take the 4th root now. Okay, so we always match that exponent. We take the 4th root, and again, we'll talk about how to do that on the calculator. So we get b equals 1.3233. All right, so let's make a note about rounding here. Okay, we always use 4 decimal places. Okay, so we want our base here to have 4 decimal places. All right, so that's our b value. Let's write our equation. So remember, we plug back in just our a and b. Okay, x and y stay variables. So this is our equation. Okay, which we're going to use now in part 2 at the bottom here, because it says how many bacteria can be expected after 12 hours. This is a time, which is an x value. So we're going to plug that into our equation for x. Okay, important that we do order of operations here. So you would evaluate this exponent and then multiply by 7,500. Okay, so it's really, really important. If you could plug it all into your calculator at the same time, just make sure you use parentheses. Okay, and again, we're going to round. Always round to 4 decimal places for our answer. Okay, so we caught those bacteria maybe mid-cell division. All right, because we have 0.385. Okay. All right, let's take a look at rate. So the equations look kind of similar, except instead of b, we now have 1 plus r and 1 minus r. So that becomes our base. Okay, so the base here is either 1 plus r or 1 minus r. And we differentiate which one to use depending if the problem indicates its growth or decay. So growth is going to be plus because we know growth has a base that's greater than 1, and decay is going to be minus because we know that's in between 0 and 1. We get those fractions or decimals for decay. So it's important that we choose correctly if it's plus or minus. When we're doing non-rate, we don't have to think about if the problem is a growth or decay. So if the first U.S. Census was conducted in 1790, at that time there were 3,929,214 people. Okay? Since then, the population has grown by approximately 2.03% annually. Write an equation to model the situation. So the thing about rate problems, you're going to see a percentage. And that's actually how you're going to tell the difference between rate and non-rate, because I'm not going to identify it for you on your quiz. So if you see a percentage, automatically you know, okay, this is a rate problem. And now I want to look for context clues to figure out if it's growth or decay. Well, I see the word right there. I see grown. So this is a growth problem, which means I'm going to use the equation of 1 plus r. Okay, now we have to remember when you're working with a percent, okay, we don't take a percentage and plug it into an equation or a formula. Okay, we always change a percent into a decimal. Okay, so you can either divide by 100, divide your percentage by 100, or you can swoop your decimal point 2 places to the left. Totally up to you. Okay, but either way, this is the decimal value that we're working with, and this is the r that we're going to plug into our equation. So the really nice thing about rate problems is there's no solving to be done. Okay, so we have our rate 1 plus. Okay, and now we're going to go back to our problem and see, well, what was our initial value? Well, it says the first census, and this was the population. Okay, so that's our initial value. That was our starting value. Okay, and the only thing that I'm going to ask that you do with rate problems is just simplify over here. Just clean that up and actually add them together. And that is our equation. We didn't have to solve for the base for this one. That makes rate so much nicer, and it makes rate so obvious because, oh, we see a percentage. That should be our number one indicator. Okay, let's try one more of these. So a cup of green tea contains 35 milligrams of caffeine. Okay, the average teen can eliminate approximately 12.5% of caffeine from their system per hour. Write the equation to model the situation, then estimate the amount of caffeine in a teenager's body 3 hours after drinking. So there's a lot of information here. Okay, and the first thing that we should know is they're asking us to do 2 different things. So the first is to write an equation, and the second is to then estimate a value. Okay, so we want to make sure we don't try and do too much at the same time. All right, so I see a percentage, which tells me this is going to be your rate. And now I need to know, is it growth or decay? So I want to look for a key word. Well, I see it says eliminate. Okay, well, eliminate would indicate a decrease, which to me means it's decay. So I'm going to use the formula that has 1 minus in it. Okay, and I'm going to take my percentage and I'm going to convert it into a decimal. Okay, now I have to figure out, so this is my R, I have to figure out, well, what is my initial value? So a cup of green tea contains 35 milligrams. Well, that's the only other value that's left in the problem. And that's where it starts. Okay, so that's my A value. Okay, and again, with rate, there's not a whole lot that you have to do here. So I'm just going to ask that you simplify your base. So we're going to make this 35 times, oh, I added an extra 1 in there. Sorry. So we're just doing 1 minus 1.25, and that's where we get that 0.875. Okay, so we see this equation too. This indicates that it's going to be a decay that I chose earlier because my base is in between 0 and 1. Okay, now the last thing for me to do, so this was step 1, so now step 2. It says estimate the amount of caffeine after 3 hours. Okay, so 3 hours is a time, and we know that time is always x. So we're going to plug that into our equation. Okay, you can plug that into your calculator exactly as it appears. Otherwise, make sure that you do order of operations and you take care of that exponent first. And this would be milligrams. Okay, it would be nice to put a little unit label on that. Okay, and remember we always round to 4 decimal places. All right, so those are your 2 formulas, 2 different types of word problem examples. Okay, definitely make sure that you have all of these notes complete and you write down any questions that you have as you're watching it now while it's fresh so that you remember to ask me in class. All right, thank you so much for watching, guys. I will see you soon.